So now that we know how to find reference angles, let's talk about using reference angles to help us in evaluating trig functions. Reference angles are useful in that they allow us to greatly extend the scope of any exact trigonometric value. Think to the unit circle when you see exact trigonometric values. For any angle theta and its reference angle theta prime, the magnitude of the value of each trigonometric function of theta is equal to the value of the same trigonometric function of theta prime. What does this mean? Well, the absolute value of the sine of theta, when you hear the word magnitude in math, we're talking about absolute value. The absolute value of the sine of theta is equal to the sine of theta prime. The absolute value of the cosine of theta is equal to the cosine of theta prime. And the absolute value of the tangent of theta is equal to the tangent of theta prime. And the same goes for each one of their reciprocals. This is saying that the only difference between the sine of theta and the sine of its reference angle is possibly the sine, S-I-G-N, whether or not it is positive or negative. All right? Other than that, the values will be identical. Same for cosine. The only difference between cosine of an angle and the cosine of its reference angle is possibly whether or not it is positive or negative. All right. And same thing for tangent. The tangent of theta will be identical to the tangent of its reference angle, except it could potentially be negative. So, why does this help us? Well, this means that we can find the value of a trigonometric function of any angle theta by one two-step process here, determining the function value for the associated reference angle theta prime. So, in other words, evaluate the trig function of the reference angle, and then step 2, affixing the appropriate sign, positive or negative, to the function value that we just found, depending on the quadrant in which theta lies. One thing to make note of here, the 6 trigonometric functions of theta prime are always going to be positive. And the reason being is, as we said, reference angles are acute angles, which if you were to draw them in standard position, would place them in the first quadrant. And all of the trig functions are positive in the first quadrant. That means each one of these quantities here, sine, cosine, tangent, cosecant, secant, and cotangent of theta prime, the reference angle, always has to be positive. And hopefully that makes sense in each one of these equations. So again, what are we going to do? Determine the function value for the associated reference angle, evaluate the trig function of the reference angle, and then determine whether or not we want our answer to be positive or negative, depending on the quadrant of the original angle theta. Let's try one out here. Evaluate the cosine of 4 pi over 3. Use the reference angle to help. Well, always a good idea to get a good picture of what's happening. The angle 4 pi over 3. Now, that is one of your special angles on the unit circle, and you certainly could find the angle on the unit circle and answer the question in that manner. However, here we're going to show you how we're going to use the reference angle to do the same problem and explain why it might be helpful to use reference angles instead. So, we know this angle has to be in the third quadrant, right? This is 4/3 of pi. That's greater than 1 pi, but less than 1.5 pi. So we can draw out some angle in the third quadrant to get an idea of what's happening here. Here's my angle 4 pi over 3. Let's now find the reference angle. Remember, reference angles are measured from the terminal side of our angle theta to the nearest x-axis. This right here would be our reference angle theta prime. So let's find theta prime. And as usual, we have to use a little bit of critical thinking to figure out what theta prime is going to equal. Well, notice that theta prime is a piece of this entire angle 4 pi over 3. And if we were to take this angle, which would be pi, and add theta prime, we would get 4 pi over 3. In other words, pi plus theta prime has to equal 4 pi over 3. And if we want to solve for theta prime algebraically, we would subtract pi from both sides of the equation. And if we want to subtract fractions, we have to get a common denominator. This would be 4 pi over 3 minus 3 pi over 3, which gives us theta prime is equal to pi over 3. Another way to find that reference angle would be to consider, okay, how much farther past pi do I have to go to get to 4 pi over 3? Well, I have to add another third of pi. Therefore, theta prime must be 1/3 of pi, or pi over 3. So, in the end, our goal is to evaluate the cosine of 4 pi over 3. We can do so by evaluating the cosine of our reference angle and then affixing the appropriate sign, because we know that the magnitude of the cosine of 4 pi over 3 has to equal the cosine of our reference angle, pi over 3. In this case, however, we know that the cosine of 4 pi over 3 must be a negative quantity, because the angle 4 pi over 3 is in the third quadrant, and cosine corresponds to the x-coordinate, so the x-coordinate has to be negative. Therefore, we can say that the cosine of 4 pi over 3 is equal to -1 times the cosine of pi over 3. Notice that this right here is the cosine of the reference angle. So we can find the cosine of the reference angle and affix the appropriate sign in front of it. Again, we have to put a negative sign in front because we know cosine of this angle 4 pi over 3 has to be negative because the angle is in the third quadrant. Now, can we evaluate the cosine of pi over 3? Yes, the cosine of pi over 3 is 1/2. So this is -1 times 1/2, which means that the cosine of 4 pi over 3 is equal to -1/2. There we have our answer. All right. So, could we have solved this just using the unit circle? Absolutely. Why is the reference angle helpful? Well, reference angles now only require you to memorize the first quadrant of our unit circle. Okay, all of these other angles, the reference angles, will all be related to angles that are in the first quadrant of our unit circle. All right. If you like memorizing the whole unit circle, that's perfectly fine and acceptable. If you want to use reference angles, you can use this technique as well. Let's take a look at another one. Again, note that a negative sign was put in front of cosine pi over 3 because the angle theta is in quadrant 3. Evaluate the cosecant of 11 pi over 4. Use the reference angle to help. When in doubt, draw it out. Let's draw a picture. Now, 11 pi over 4. This is an angle that is greater than 2 pi. And whenever you see angles that are greater than 2 pi, helps to write it as a mixed number. How many times does 4 go into 11? Well, it goes in twice, and there's a remainder of 3. Therefore, 11 pi over 4 is the same thing as 2 3/4 pi. Well, 2 pi is 1 full revolution, and then I have to add 3 more quarters of pi. That brings me to right here. All right, so we've drawn out our angle theta. Now let's identify the reference angle theta prime. Reference angle is the angle between our terminal side of theta and the closest x-axis. Remember, it has to be an acute angle. So there we have the angle theta prime. Now, to find theta prime, what we can do in this case is simply count out fractions of pi. Notice, how much farther would we have to travel to get to 3 pi? 1.5 revolutions. Well, we would have to tack on another pi over 3 here. So to answer that question, we would have to tack on another pi over 4 here. So to answer that question, theta prime is equal to pi over 4. Right? To get to 3 pi, I'd have to add another fourth of pi. Pi over 4 is our reference angle. So our goal now is to evaluate the cosecant of 11 pi over 4. Well, the cosecant of 11 pi over 4 is going to be equal to the cosecant of our reference angle, but possibly different in sine. The magnitude of the cosecant of theta is equal to the cosecant of theta prime. That's our relationship. Well, this angle, 11 pi over 4, is located in the second quadrant. And we know that cosecant corresponds to the y-coordinate. Cosecant is the reciprocal of sine. And because we're in the second quadrant, the y-coordinates have to be positive. Therefore, sine has to be positive, meaning that the cosecant of 11 pi over 4 is equal to cosecant of pi over 4. Here I have the cosecant of the reference angle. I've placed a plus sign in front of it because our angle 11 pi over 4 is in the second quadrant. Well, what does this mean? Cosecant of 11 pi over 4 is equal to, cosecant's the reciprocal of sine, so that's 1 over the sine of pi over 4, the reference angle, and the sine of pi over 4 is root 2 over 2. Therefore, the reciprocal is 2 over root 2, which when we rationalize and simplify, that gives us root 2 for our final answer. All right, so again, using the reference angle allowed us to rewrite this in terms of an angle that's in the first quadrant. The whole idea with reference angles is that now we only have to know the first quadrant of the unit circle. However, if you are more comfortable dealing with the fractions, that's perfectly acceptable. All right, we could also say that this angle, 11 pi over 4, terminates in the exact same location as the angle 3 pi over 4. So another acceptable way to go about solving this problem would be that the cosecant of 11 pi over 4 is the same thing as the cosecant of 3 pi over 4, which we could then solve out using the unit circle. And again, we would get the same answer, root 2. So if you like using reference angles because it only requires you to know the first quadrant of the unit circle, that's great. If you want to count them out, that's perfectly fine as well. All right, note that in this case, the trig function remains positive because the angle theta is in quadrant 2. Let's try one last one. Evaluate the tangent of negative 19 pi over 6. Use the reference angle to help. Well, again, here I have an angle. This one is going to be greater than negative 2 pi. So let's again write this as a mixed number. 6 goes into 19 3 times with a remainder of 1. Therefore, negative 19 pi over 6 is negative 3 1/6 pi. Well, let's draw it out. Going all the way around in the clockwise direction would be negative 2 pi, negative 3 pi to here, and then I have to tack on another sixth of pi. All right, there I have my angle theta. And my reference angle, again, is the acute angle between the terminal side and the closest x-axis. There we have theta prime. Well, in this case, how can we find theta prime pretty easily? Well, how much farther did we have to go beyond negative 3 pi? We had to tack on another pi over 6. Therefore, our reference angle is going to be pi over 6. Remember that reference angles are acute angles. They're between 0 and pi over 2 radians, so they're always going to be positive. Okay, so now we're trying to evaluate the tangent of negative 19 pi over 6. We can do so by evaluating the tangent of the reference angle, pi over 6, and then determining the sign that needs to be put in front. Well, our angle theta ends in the second quadrant, and we know that tangent is going to be negative in the second quadrant. Therefore, we can say that the tangent of negative 19 pi over 6 is equal to negative 1 times the tangent of pi over 6. Again, we evaluate the tangent of the reference angle and put the sign that we need in front of it. Tangent of negative 19 pi over 6 must be negative because it is in the second quadrant. All right, well, how do we evaluate tangent of pi over 6? Tangent's y over x. The y-coordinate associated with pi over 6 is 1/2 divided by root 3 over 2. Doing out the algebra, we end up with negative 1 over root 3, Rationalizing that quantity gives us negative root 3 over 3 for our final answer. Okay, and again, note that because a negative sign was put in front of tangent pi over 6, because the angle theta is in quadrant 2 and the tangent value has to be negative. So that's how we can evaluate using reference angles. Is it absolutely necessary? No. Another way to think about this is to consider just using another angle that shares the exact same terminal side. Notice that our angle negative 19 pi over 6 terminates in the exact same location as the angle 5 pi over 6. So what would be another way to go about solving this? We could say that the tangent of negative 19 pi over 6 is equal to the tangent of 5 pi over 6 and go from there. All right, just using our unit circle. The purpose of reference angles, they allow us to only have to use the first quadrant of our unit circle.